Hello and welcome to the next topic of continuity and differentiability. So in the previous lectures, we completed continuity as well as differentiability. Ahead in this chapter, we are going to start with differentiation, that is finding derivative of a function. Okay, now for that, let me tell you that we have already done derivation in the previous classes, that is class 11th, of course. So we are not going to do some basic problems here, but starting with basic problems, and we are going to move towards different properties and different problems of differentiation. Okay, so let's start with some basic rules which I think we will revise, which we have learned from class 11th. This is known as power rule. D by dx of x raised to n is equal to n multiplied by x raised to n minus 1. The power gets multiplied, and the power gets multiplied with x raised to n minus 1. That is, the original power gets decreased by 1 for all x belonging to real numbers. Similarly, d by dx of ax plus b the whole raised to n. Now you can differentiate it by simplifying more, but if you remember this formula, then it's very easy. This will be n multiplied by ax plus b the whole raised to n minus 1 multiplied by a. This is the whole answer. Okay, if you find it normally also, normally means I'm I mean d by dx of ax plus okay, so first, because there is a power and we have to apply, I think we have to apply chain rule. So you cannot differentiate it normally. You have to apply chain rule, and then you will get this answer. Okay, n multiplied by ax plus b the whole raised to n minus 1 multiplied by a for all x belonging to real numbers. Now, you might be having this doubt in your mind, what is chain rule? So I think we have covered chain rule in class 11th. If not, I'm going to give you an example about chain rule as well as we move ahead in the lecture. Okay, so next one, the derivative of constant function is 0. D by dx of c is 0, such that d by dx of 5 is 0. Any constant function, its differentiation will be 0. Next, additive constant vanishes on differentiation. So suppose with a function you have an additive constant c, on differentiation it gets vanished. Okay, because differentiation of a constant function becomes 0. The derivative of scalar multiple of a function is the scalar multiple of the derivative of the function. Okay, so if you have a function a, f of x is equal to a multiplied by g of x, and if you find derivative of a function f of x, then a will be still outside and g of x will get converted into g dash of x. That is, we will find the derivative of g of x and multiply it with a. The derivative of sum or difference of the functions is the sum or difference of their derivatives. So if we have f of x is equal to g of x plus or minus h of x, then simply the derivative of f of x, that is f dash of x, becomes the sum or difference of the derivative of g of x and h of x. And similarly, we can distribute derivative over the sum and differences of n number of functions. Okay, derivative of the product of two functions. This is known as product rule. So if we have product of two functions, now remember, product of two functions is not the function of a function, composite function. Okay, that is, composite function can be only derivable with the help of chain rule. Okay, we are not talking about chain rule yet. This is just the product rule. We are finding the derivative of the product of two functions. It is equal to first function multiplied by the derivative of second function plus second function plus second function multiplied by the derivative of first function. So if we have three functions in product, you can apply product rule in the similar pattern. Okay, then comes one peculiar question, one peculiar property which we have not studied in detail, or we have not seen this earlier. But yeah, if you use your quotient rule, you can differentiate this. But yeah, if not, then you can, if you want, you can remember this function. If the function is reciprocal of a given function, then the differentiation of such a function is equal to negative of differentiation of the denominator upon the square of the denominator. Negative of the differentiation of denominator upon square of the denominator. What is denominator? H of x. H of x is the whole function. Okay. Then the quotient rule, derivative of quotient of two functions. Two functions are in numerator and denominator, quotient, they are divided with each other. It is the derivative of this kind of quotient is equal to denominator multiplied by the derivative of numerator minus numerator multiplied by the denominator derivative of the denominator upon square of the denominator. Okay, so this is what you need to apply, but this is applicable only when h of x, that is the denominator function, is not equal to 0. Then there are these trigonometrical derivatives which we have seen last year. You must remember each and every one of them. D by dx of sine x is cos of x. D by dx of cos of x is minus sine x. D by dx of tan x is sec square x. D by dx of cot x is minus of cosec square x. D by dx of sec x is sec x into tan x. D by dx of cosec x is equal to minus cosec x and cot x. Now, do you see that these are applicable for all real numbers, but for tan, cot, sec, and cosec x, we do not find the derivative, or we do not consider the values of x at odd multiples or even multiples of pi by 2, because at odd and even multiples of pi by 2, the function cot x, tan x, and such, they do not have any definite values. So there is no range, right? So if the function is not continuous over there, or if the function is you can say horizontal or vertical asymptote, then it cannot be derivable at these points. Okay, so you must remember these standard formulae. Okay, then comes the derivative of a composite function, okay, using chain rule. So what is chain rule? So I'm going to give you an example to understand chain rule. We are not going to go in the detail of the proof, but I'm going to give you an example. So this is basically a formula of chain rule, where dy by dx is equal to dy by du multiplied by du by dx. So you must be thinking, what is u and what is dy by du and what is all this? So let me give you an example if you have forgotten. If you remember this very well, if you have forgotten, that's not a problem. We can understand it. Okay, let's take an example of a function y is equal to under root of sine x. Okay, now if you see over here, there are two parts in this function. This is in the form of function of a function. Okay, function of a function means f of x. So whenever you have a function of a function, that's a composite function, you cannot apply product rule. You have to apply chain rule. So how does chain rule work? See, first of all, you have to identify both the functions. So the outer function is the square root. And inside square root, there is not just x, there is sine x. So the inner function is sine x. So this is outer function, this is inner function. Okay, now I'm going to teach you, or let's say make you revise the original way of solving this, that is UV method. Okay, some people are comfortable in solving chain rule directly without UV method, but if you are not comfortable, then don't take chances unless and until you are very much sure about chain rule, solving any problems of chain rule directly. You can go ahead and do that. Okay, but if you're not comfortable, then look at this method which I'm trying to show you. Okay, now first of all, you have to consider the inner function as u. So this sine x, you have to take it as u. So let me write over here, let sine x is equal to u. Okay, so therefore, how can you write y? Y is equal to under root of u. Okay, now differentiate both sides, with respect to u, with respect to the uh, variable which is over here. Okay, so with respect to that variable, whether it is u or x or whatever, you can differentiate both the sides. So dy by du differentiating y with respect to u is equal to d by du of root u. Okay, so dy by du is equal to uh, d by du of u raised to 1 by 2, that is half multiplied by u raised to 1 by 2 minus 1, right? The original power gets decreased, so that is half multiplied by u raised to minus 1 by 2, which is, let me write over here. Okay, let me write a little bit down, which is half multiplied by half multiplied by 1 upon u raised to 1 by 2, which is 1 upon 2 root u. Now what was u? See, u was sine x. So now put the value of u over here. You get 1 upon 2 into root of sine x. 1 upon 2 into root of sine x. Okay. Now, what is the other function? See, the first function is root, outer function. The inner function is sine x. So now you have to write u is equal to sine x. And you have to differentiate both sides with respect to x. So you get du by dx is equal to d by dx of sine x. So therefore du by dx is equal to d by dx of sine x is cos x. Okay, so you got the value of du by dx. Now you must be wondering that what is this chain rule? I told you the formula for chain rule. Dy by dx is equal to dy by du multiplied by du by dx, where u is the inner function, okay, so inner function is taken as u, so we can find dy by du. Dy by dx, I'm sorry, dy by dx is equal to dy by du multiplied by du by dx. See, this u gets cancelled and we get dy by dx, but we don't have to cancel it, we just have to put the value. What is dy by dx? Sorry, dy by du. Dy by du is 1 upon 2 under root sine x. And what is dy by dx? Dy by dx is cos x. So the answer will be cos x upon 2 multiplied by under root of sine x. So whenever you get a composite function of a function, you have to solve in this manner. Do you understand? Great. Okay. There is one more important result based on this chain rule, which I want to show you over here. Please pay attention. See, y is equal to mod of x. Suppose we have modulus function. The differentiation of modulus function is equal to x upon mod of x, but not at 0. Okay, because modulus function is not differentiable at 0. We have seen that in the previous part, differentiability. Modulus function cannot be differentiable at 0. Okay, but at other points the differentiation of modulus function is x upon mod of x. How to prove that? So we know that y is equal to mod of x. Can we write mod of x is equal to under root of x square? Because under root of x square is plus minus x, and mod of x is also plus minus x. Okay, can we write root of x square as x square raised to 1 by 2? Okay, now don't do anything, just differentiate both sides. So y becomes dy by dx. We are differentiating both sides with respect to x, so y becomes dy by dx, and x square raised to 1 by 2 can be differentiated with the help of chain rule. Okay, so see, we have let me apply chain rule and show you what we are going to get. So we have y is equal to, y is equal to x square raised to 1 by 2. Okay, now differentiating both sides with respect to x. Okay, what we will get? Dy by dx is equal to, okay, now I'm directly writing dy by dx. I'm not using that UV method. We can use the UV method, but I want to show you one more way of doing this. Now I told you to identify the outer function. The outer function is raised to 1 by 2, that is under root. Outer function is under root. So inside whatever is there, we are going to keep it as it is. Okay, we are going to keep it as it is, and we are going to write it like this, is equal to d by dx of x square raised to 1 by 2, which will become 1 by 2 multiplied by x square. See, I'm not touching x square. I'm not touching x square. That is the inside stuff. I'm leaving it as it is. Raised to 1 by 2 minus 1. Right? So 1 by 2 multiplied by x square, the whole raised to minus 1 by 2. Okay? So this will be okay. One more thing. This whole thing will be multiplied by d by dx of that inside stuff. Inside stuff is x square. Inside function x square. And d by dx of x square is 2x. This will be multiplied with 2x. Okay, so this will be 1 upon 2 under root of 1 upon 2 under root of x square multiplied by 2x. 1 upon 2 under root of x square multiplied by 2x. This will become 2 will cut, and this will become x upon under root of x square. You know what is under root of x square? Mod of x. Did you understand? How did I apply the chain rule over here? I first differentiated the outer function, that is raised to 1 by 2, and I did not touch that inner function x square. I kept it as it is. Okay, so I kept that x square as u, but I did not write u. I just left it as x square. Okay, so I got this thing over here, 1 upon under root of x square, 1 upon 2 under root of x square. Of course, that 2 got cut later, and I multiplied that with the differentiation d by dx of that inner part, that is x square. Okay, so I got 2x over here, and then I simplified and I got x upon mod of x. So always remember that differentiation of mod of x is x upon mod of x when x is not equal to 0. Okay, let's start with the solved examples. The first solved example, so we have to find dy by dx, but what has been given to us? Sine square x plus cos square y is equal to 1. Now there is a function over here whose domain is y, that is cos square y, and we have to find dy by dx. So don't get offended over here that we have not learned this. Yeah, we are going to learn implicit and explicit functions separately in the next section, but till then I'll just teach you. This is very simple. Okay, focus on the steps and you will understand. So how we find this? How we find dy by dx? First thing we write is, see, what is dy by dx? Differentiation of y with respect to x. So let me write differentiating both sides with respect to x. So we get d by dx of sine square x plus cos square y is equal to d by dx of 1. Can I write it as d by dx of sine square x plus d by dx of cos square y? Yes, of course I can, which is equal to 0 because differentiation or derivative of a constant is always 0. Now this is a function of a function, sine square x. Sine square x is nothing but sine x the whole square. Now the outer function is square and the inner function is sine x. So this is composite function. We cannot differentiate it directly. We have to use chain rule. Okay, here also we have to use chain rule, but how, I'll tell you. So let me write it as cos y the whole square. Okay, so I'm going to first imagine that there is u in place of sine x. I'm just going to not touch sine x. So if I have differentiation of u square, okay, how would I differentiate? How would I differentiate? So I would just bring this 2 ahead. That is, I will write it as 2 multiplied by u, or 2 multiplied by sine x. Okay, so what I'm doing is I'm treating sine x uh, as an untouchable quantity. I will not touch sine x. So 2 sine x multiplied by uh, differentiation. Okay, so here I differentiated, or I found the derivative of the outer function, that is square function. Now the derivative of inner function, that is sine x. Okay, here also the same thing. So I'm going to treat the whole square as one function to be differentiated, which will become 2 multiplied by cos y. I imagine cos y to be some other value, simple function. Acha, multiplied by differentiation of d by dx of cos y, okay, is equal to 0. Okay, so what is so this is 2 sine x multiplied by d by dx of sine x, which is 2 sine x cos x, 2 sine x cos x, plus what we will get over here, 2 cos y multiplied by, okay, d by dx of cos y is minus sine y, but wait, here the variable is y, so you also have to do this one formality and write dy by dx. So whenever you are doing implicit differentiation, which we are going to learn, remember that whenever your domain is not in terms of x and you are differentiating with respect to x, you have to write dy by dx at the end of your differentiation. So cos y is differentiated as minus sine y multiplied by dy by dx as a formality, and here you go. Okay, so you get 2 sine x cos x, let me make some space, 2 sine x cos x is equal to, see, this is minus, this is going to become minus. Okay, so let me write it as 2 sine y cos y dy by dx. Okay, now 2 sine x cos x upon 2 sine y cos y is equal to dy by dx. Dy by dx stays here, 2 sine y cos y goes into the denominator, so therefore dy by dx is equal to sine 2x upon sine 2y, sine 2x upon sine 2y, that is the value of dy by dx. So actually you applied most of the rules of differentiation which we were discussing just now. This was just a, you can say, warm up for you. Okay, more questions are coming up. Come on, next question. Find dy by dx when ax plus by square is equal to cos y. Okay, similar question. So we have ax plus by square is equal to cos y. We have to find dy by dx. So differentiating both sides with respect to x. So d by dx of ax plus by square is equal to d by dx of cos y. Okay. Now d by dx of ax plus by square will become d by dx of ax plus d by dx of by square, okay, is equal to d by dx of cos y will become minus sine y multiplied by dy by dx, right? There is no issue, we just now did it. Cos y, we have cos y, so minus sine y into dy by dx. Okay, here d by dx of ax, a is the constant, so it will come out, and d by dx of x is 1, so here only a will remain. Here b will come out constant, and I'm going to get d by dx of y square. Okay, so this will be minus sine y dy by dx, no problem. Okay, so here I'm going to get a plus b multiplied by, okay, d by dx of y square. So what is the differentiation of y square? 2y. Okay, so I'm going to write it as 2y dy by dx is equal to minus sine y dy by dx. Okay, now I'm going to do some shifting. Uh, let me shift a to the other side. So this will become sine y dy by dx, sine y dy by dx plus b multiplied by 2y multiplied by dy by dx is equal to minus a. No problems, right? Okay, so this will give me, see, I will take out dy by dx common. Inside I will be getting sine y multiplied by, sorry, plus, sorry, plus 2by or 2yb is equal to minus a. So dy by dx is equal to minus a times, sorry, minus a by sine y plus 2by. Correct? So this is your value of dy by dx. I hope you now understand these kind of complex differentiation, how to carry out. They are not complex, they are simple. You just need to take care of some few things, and wherever there are chain rule, you need to be extra careful. All right, okay. So they want us to apply chain rule over here. Use chain rule to find dy by dx if y is equal to 2x minus 1 upon 2x plus 1 the whole square. Okay, let's apply chain rule. So y is equal to 2x minus 1 upon 2x plus 1 the whole square. Differentiating both sides with respect to uh, x. So we get dy by dx is equal to dy by dx is equal to, see, here we have got function of a function. Of course, the outer function is the square function. Okay, so we will write d by dx of 2x minus 1 upon 2x plus 1. So dy by dx equals to, this is the whole square. Okay, so I'm going to treat this inside stuff, I'm not going to touch, as untouchable. Inside stuff cannot be touched. Okay, so how I'm going to now differentiate? Now I'm going to uh, think that what is d by dx of x square? It is 2x. So basically I'm going to write it as 2 multiplied by 2x minus 1 upon 2x plus 1. And now I'm going to differentiate that inside stuff, d by dx of 2x minus 1 upon 2x plus 1. Okay, so now for differentiating this, I'm going to use the quotient rule. Quotient rule has to be used now. Okay, so be careful. So dy by dx is equal to, if 2 gets multiplied, you need to multiply 2. No, just keep it outside. 2x minus 1 upon 2x plus 1. See, what does the quotient rule tells us? Quotient rule tells us that uh, numerator multiplied by differentiation of denominator, sorry, denominator into differentiation of numerator minus numerator multiplied by differentiation of denominator upon denominator square. I don't know if you got it, but yeah, you need to remember the quotient rule. Okay, so this will give us uh, denominator, that is 2x plus 1 multiplied by d by dx of 2x minus 1 minus uh, 2x minus 1, I'm just going to put a bracket for safety, multiplied by d by dx of 2x plus 1 the whole upon 2x plus 1 the whole square. 2x plus 1 the whole square. Okay, great. So dy by dx is equal to, how to differentiate these things over here? See, d by dx of 2x minus 1. So we have 2x minus 1, 2x plus 1, does not matter. I'll just ignore these plus 1s or minus 1s. What is d by dx of 2x? See, 2 will come out and d by dx of x will be equal to 1. Okay, so this is just going to give us 2, d by dx of 2x minus 1. If you want me to show you, see, here it is, d by dx of 2x minus d by dx of 1, and d by dx of 2x is nothing but 2 into 1 minus d by dx of 1 is 0. So 2 into 1 minus 0, which is 2 minus 0, which is 2. So I'm going to get only 2 over here. Here also I'm going to get only 2. So 2 will be multiplied with 2x minus 1. So that will be 4x plus 2 minus 2 bracket 2 bracket uh, yeah, because there is a minus sign, so that's why I'm writing. Otherwise, I could have made a bracket also and directly multiplied it. Okay, let me just do that. Minus bracket 2 multiplied by 2x minus 1 is 4x minus 2, bracket close, the whole upon 2x plus 1, the whole square. Okay, so dy by dx is equal to uh, let me write it as 2 multiplied by 2x minus 1, the whole upon 2x plus 1 multiplied by 4x plus 2 minus 4x plus 2. So 4x minus 4x will cut and plus 2 will become plus 4, the whole upon 2x plus 1, the whole square. Okay, can it be cut with anything? I don't think so. So 4 2s are 8, bracket 2x minus 1 upon 2x plus 1, the whole cube. Can this be simplified further? I don't think so. A plus b the whole cube is a plus b bracket a square plus ab, a square minus ab plus b square. Yeah, so it cannot be cut with anything. Okay, so I think this is the final answer. Uh, 8 bracket 2x minus 1 upon 2x plus 1 the whole cube. Let's check the answer. I don't know whether it's correct or not. Let me check. Hey, yeah, it's correct answer. Okay. Next question. So differentiate sine of cos x square with respect to x. Okay. The next question is differentiate sine of cos of x square with respect to x. Now look closely. Okay, we have y is equal to sine of cos of x square. This is function of a function of a function. Remember, it is like this: f o f o f, or you can say f of x, sorry, f of f of x, like this, function of a function of a function. Okay, and whenever something like this you need to differentiate, you need to apply chain rule, because this is a composite function. Okay, so here we have got three function inside a function, the three, you can say, brackets inside brackets, function inside function, three layered function. Okay, before this we had two layered function, so there was a u involved. Here u and v both will get involved. See how. Here first I want you to identify which is the innermost function, so let that innermost function be v. Okay, so let x square is equal to v. Okay, then which is that outer function, you can say, which is uh, cos of x square, that is the outer function. Okay, and the outermost function is sine of cos of x square, sine of something, so that cos of something is the outer function. So the let cos of x square is equal to u. Okay, therefore cos of x square is also, sorry, so let me write it like this: let x square is equal to v, and cos of x square is equal to u. Therefore, y is equal to sine of u. Y is equal to sine of u. Now we have to start differentiation from the outermost function. So y is equal to sine of u, differentiating both sides with respect to x, you get dy by dx is equal to, dy by du. Differentiating both sides with respect to u, not x. So dy by du is equal to d by du of sine u. So dy by du is equal to cos u. Now what is u? U is equal to cos of x square. Cos of x square. Okay. Cos of x square can also be written as cos of v. Okay, remember that. So dy by du is cos of u, and u is equal to cos of x square. So we can write it as cos of x square. Okay, so this is the first step. We have differentiated the outermost part of the function. Now let's go inside. Now inside we have got u is equal to cos of v. U is equal to cos of v. Now differentiating both sides with respect to v. So we get du by dv is equal to d by dv of cos v. So du by dv is equal to d by dv of cos v is minus sine v. D by dv of cos v is minus sine v. So we have got du by dv. Okay, and the last innermost function is x square. Okay, so x square is equal to v. Remember that. Let's write it like that. So v is equal to x square, and differentiating both sides with respect to x. So dv by dx is equal to d by dx of x square. So d by dx, dv by dx is equal to 2x. Right? Now, what we have to find? We have to find dy by dx. Remember that. So dy by dx can be found easily. Therefore, dy by dx is equal to du by dy. I'm sorry, dy by dy by du multiplied by uh, du by dv, du by dv multiplied by dv by dx. So here du will cut, dv will be cut, and dy by dx we will get. But we know the value of du by dy, du by dy by du by dv, and dv by dx. So just put the values here. The first value dy by du is cos of cos x square, cos of cos x square, cos of cos x square multiplied by du by dv, multiplied by du by dv minus sine v. Hey, we didn't put the value of v. Just a moment, let me just simplify this. See, v is equal to x square, so minus of sine x square. Okay, so here we'll get into minus of sine x square multiplied by dv by dx, and dv by dx is nothing but 2x. So let me just simplify this. This will become minus 2x multiplied by sine, is it sine x square? Yeah, sine x square. So sine x square can be written as sine of x the whole square multiplied by cos of x the whole square. Is it cos of x square? Yeah, cos square x. No, it is cos u, and cos u is cos of x square. Correct. Yeah, so this should be the final answer. Minus of 2x multiplied by sine of x the whole square, that is sine x square. We can write it as sine x square also. Okay, so let me just give you one more option for this. Minus 2x multiplied by sine x square multiplied by cos x square. Okay, so this is your final answer. Let's check whether it is correct or not. Minus 2x multiplied by sine of x square multiplied by cos into cos of x square. So that is correct. Okay, now you must be thinking that this UV method is little longer. So is there any shorter method like how they have done in the answer? Yes, there is a shorter method. Let me show you that method as well. So we have y is equal to sine of cos of x square, sine of cos of x square. Okay, now you know that the innermost function is x square. Okay, so what we need to do is we need to differentiate uh, starting from the outer function and then going towards the inner function. Okay, so we'll differentiate like this. See, dy by dx is equal to d by dx of sine of cos of x square multiplied by d by dx of the inside one, that is cos of x square multiplied by d by dx of x square. Okay, so this is very easy. Now this, see, don't touch the inside stuff. Here the inside stuff is cos of x square. I have to imagine that cos of x square is nothing but x. So what is the differentiation of sine x? Cos x. So just write it as cos of cos of cos of x square, cos of x square. Okay, here don't touch the inside stuff, keep it as it is, just imagine it to be x. Okay, so what you will get cos of uh, what is the differentiation of cos x? Minus sine x. So you will get minus of sine of x square multiplied by 2x. So this will be minus 2x multiplied by sine x square multiplied by cos of cos x square. That was your answer, right? So this is easier. If you do it like this, it is easier, it is shorter, but yeah, you should be able to figure out the differentiation without making any mistake. Otherwise there is UV rule, so both the methods are explained to you. Whichever you like, you can apply. Next question. If y is equal to under root of 1 minus x upon 1 plus x, prove that 1 minus x square into dy by dx plus y is equal to 0. Okay, we can prove that, but first we need to find the value of dy by dx. So we'll start from there. Y is equal to under root of 1 minus x upon 1 plus x. Okay, so differentiating both sides with respect to x. Okay, now understand that if you differentiate both sides with respect to x, on left side you get dy by dx, on the right side you get d by dx of under root of 1 minus x upon 1 plus x, the bracket close. Okay, here actually 1 minus x is there. Let me just write it properly. 1 minus x. Okay, so how to differentiate this? Again, it is chain rule will be applicable because this is function of a function. Outside there is a root, and inside root there is a function, and that function can be differentiated by using quotient rule. So that we are going to do, but let us first go step by step and write uh, d by dx of under root of 1 minus x upon 1 plus x multiplied by d by dx of 1 minus x upon 1 plus x. Now, as I told you, don't touch this inside stuff. Just consider it to be x. So what is the differentiation of root x? See, root x can be written as x raised to 1 by 2. Okay, so can we write it as d by dx of 1 minus x upon 1 plus x the whole raised to 1 by 2? Yes. And this as d by dx of 1 minus x upon 1 plus x. So this half will be multiplied in front, half multiplied by 1 minus x upon 1 plus x the whole raised to minus 1 by 2, the whole raised to minus 1 by 2, correct, because 1 by 2 minus 1 is minus 1 by 2. Okay, so we will simplify this. We are going to simplify this, but before we simplify this, let me just find the differentiation of this quickly. So if you remember the quotient rule says that d by dx of numerator upon denominator will be denominator, that is 1 plus x multiplied by differentiation of numerator, that is 1 minus x, minus numerator, which is, let me put a bracket over here for safety, uh, okay, minus numerator, that is 1 minus x multiplied by d by dx of denominator, that is 1 plus x, and bracket close, and the whole upon 1 plus x the whole square. Okay, so okay, let me write it from here. So is equal to half multiplied by, okay, we have 1 minus x upon 1 plus x the whole raised to minus 1 by 2. Can I write it as 1 plus x upon 1 minus x the whole raised to 1 by 2? Yes, definitely. Okay, what is this? 1 plus x into d by dx of 1 minus x. See, d by dx of 1 minus x will be d by dx of 1 minus d by dx of x. So d by dx of 1 will be 0, minus d by dx of x will be 1. So 0 minus 1 will be minus 1. Okay, so here I'm going to get minus 1. And this minus 1 is going to get multiplied with 1 plus x. And here I'm going to get 1. Okay, remember that d by dx of 1 plus d by dx of x is nothing but 1. So now you know that what's going to happen here in the numerator. Okay, so multiplied by, as I told you, d by dx of 1 minus x is minus 1. So minus 1 multiplied with 1 plus x, 1 plus x minus bracket 1 minus x multiplied with 1 minus x multiplied with d by dx of 1 plus x, which is nothing but 1 uh, 1 minus x. Nothing will change here. The whole upon 1 plus x the whole square. I will just keep it 1 plus x the whole square for a moment. Okay, so this will be 1 by 2 multiplied by under root of 1 plus x upon 1 minus x multiplied by, this will become minus 1 minus x minus 1 plus x the whole upon 1 plus x the whole square. Okay, plus x minus x will cut, minus 1 will become minus 2. So 1 by 2 multiplied by under root of 1 plus x upon 1 minus x multiplied by minus 2, just minus 2, not minus 2x, minus 2 upon 1 plus x the whole square. Okay, so minus 2 plus 2 will get cut, so we can write it as see, now this has a power of 2 and this has a power of half. We can actually simplify it. Okay, so let me write it like this: minus 1 multiplied by 1 plus x raised to half multiplied by 1 plus x raised to minus 2. See, this goes up, becomes minus 2, the whole upon under root of 1 minus x. I'm going to simplify that further. So minus 1 multiplied by, okay, these two powers will get added now. So minus 2 plus 1 by 2 is minus 1 upon 1 by 2. Minus 1 upon 1 by 2 is minus 3 by 2. So 1 plus x raised to minus 3 by 2, the whole upon under root of 1 minus x. Yeah, you can simplify this also further if you want. But let me check the answer. Hey. Answer is not here yet. But because we have got the value of dy by dx, we have to substitute it in this particular equation. Okay, let's substitute it in the LHS. LHS is 1 minus x square into dy by dx. So what is the simplest form of dy by dx which we could write? Dy by dx was minus of root of 1 plus x upon 1 minus x. Wait, minus of root of 1 plus x upon 1 minus x minus of root of 1 plus x into 1 minus x multiplied by 1 upon x the whole square multiplied by 1 plus x the whole square, right? One plus x the whole square plus y. Okay, I think the value of y is given over here. We can simplify it now. So 1 minus x square multiplied by, okay, so I will just I will put my minus sign here in front of it. Write multiplication of 1 plus x upon 1 minus x and multiplication of 1 upon 1 plus x the whole square plus under root of 1 minus x upon 1 plus x. Okay. So this whole thing is 0. That's what they are asking us to prove. Okay, we can prove it by simplifying this whole thing over here, which looks like, definitely looks like a mess. So let's first check whether our differentiation is correct or not. And it is a mess. So our differentiation is minus of 1 upon 1 plus x under root 1 minus x square. That looks a little strange. Let me check it. Minus of, okay, so I think they have taken they have simplified it further. Yeah, I think I should simplify it here and then find it. Let me just do it for you. Okay, I know it is a little boring, but कुछ नहीं कर सकते, करना ही पड़ेगा इसको. ठीक है, तो इसको what I'm going to do is I'm going to do rationalizing the denominator. So root of 1 plus x upon root of 1 minus x multiplied by root of 1 let me write it as root of 1 plus x upon root of 1 plus x, okay, multiplied by 1 upon 1 plus x the whole square. Okay, so this is going to become root of 1 plus x into root of 1 plus x is 1 plus x, and this is root of 1 minus x into 1 plus x is root of 1 minus x square multiplied by under 1 upon 1 plus x the whole square. Okay, so this is going to get cut with the square, and finally you are going to get 1 upon, hey, where is the minus sign? There was a minus sign here, right? So there is a minus sign, of course. So minus 1 upon uh, under root of 1 minus x square multiplied by 1 plus x. Okay, yes, I think this is simple and this is easy. Okay, now this is the value of dy by dx which we wanted. So there was some complications where we went into, so that should be taken care of now. Okay, तो हमने जो उसका रैशनलाइजिंग द डिनोमिनेटर किया वो पहले ही कर लेना चाहिए था, कोई बात नहीं। ये dy by dx की वैल्यू है ना, इसको भी हटाना पड़ेगा। Okay, so what you have to prove? LHS is equal to 1 minus x square multiplied by dy by dx. Now dy by dx we have just found out, minus of 1 upon 1 plus x under root 1 minus x square, okay, plus y. Now what is y? Y is under root of 1 minus x upon 1 plus x. Under root of 1 minus x upon 1 plus x. Is it so? Is it so? 1 minus x upon 1 plus x? Yes. Okay, now simplify this and try to get 0. So 1 minus x square is nothing but 1 plus x into 1 minus x multiplied by minus 1 upon 1 plus x into under root of 1 minus x square plus this will become under root of 1 minus x upon under root of 1 plus x. Okay, I'm just separating for the sake of LCM if required. Okay, this 1 plus x will cut with this 1 plus x, and we are getting minus of 1 minus x upon under root of 1 plus x square. Now under root of 1 plus x square can be written as, see, this will become easy. Under root of 1 minus x square can be written as under root of 1 plus x into 1 minus x plus under root of 1 minus x upon under root of 1 plus x. Don't lose it, please. So this is minus of 1 minus x upon, see this here, uh, this under root of 1 plus x into 1 minus x can be written as under root of 1 plus x multiplied by under root of 1 minus x plus under root of 1 minus x upon under root of 1 plus x. So now you know what is the LCM going to be. So LCM is going to be under root of 1 plus x into under root of 1 minus x. So here under root of 1 minus x will be multiplied, and here 1 will be multiplied. Let me take it to a bigger, larger area. This is a big question. This is not a small, simple question. So that's why it is taking time. But let it take time. We have to deal with these kind of questions, simplifying them. So minus of 1 minus x plus this will become under root of 1 minus x into under root of 1 minus x, just 1 minus x, the whole upon under root of 1 plus x into under root of 1 minus x. Now see, minus of 1 minus x plus 1 minus x will both cut and become 0, and 0 upon anything is 0. So we have proved that LHS is equal to RHS. Yeah. So if you want to prove it properly, step by step, then it will take time. It is not going to be easy, but yeah, it is doable. Okay, next question. Okay, next question. Y is equal to y is equal to x plus under root of x square plus a square the whole raised to n, and we have to prove that dy by dx is so and so. So basically we have to find dy by dx. So differentiating both sides with respect to x. Let's make our playground a little bigger. Okay, so differentiating both sides with respect to x, we get dy by dx is equal to d by dx of this whole thing, x plus under root of x square plus a square, the whole raised to n. Now I can smell function of a function over here. Definitely there is a function of a function. Okay, so I'm going to write it as, yeah, this one will be written as it is. With this I'm going to multiply. See, the inside stuff will be left as it is. Okay, the inside stuff will be left as it is. With this I'm going to multiply d by dx of x plus d by dx of under root of x square plus a square. Again, here that inside stuff, because this is also function of a function, this inside stuff will be left as it is, and with this I'm going to multiply. So this is chain rule inside a chain rule. Okay, d by dx of under root of x square plus a square multiplied by d by dx of ब्रैकेट के अंदर x square plus a square. ओके, एंड ब्रैकेट क्लोज. अब बस इसको सिंप्लीफाई कर दोगे तो तुम्हारा आंसर आना चाहिए. लेट्स सी. So what is d by dx of this, where we don't have to touch this inside stuff? It is going to be n multiplied by x plus under root of x square plus a square ब्रैकेट क्लोज raised to n minus 1. ठीक है, multiplied by ब्रैकेट में d by dx of x is 1 plus d by dx of under root of x square plus a square. अंदर के स्टफ को टच नहीं करना है तो ये रेज टू 1/2 हो जाएगा. तो यहाँ पे मैं लिखूंगा प्लस, लेट मी पुट अ ब्रैकेट, सॉरी, राउंड ब्रैकेट. सो राउंड ब्रैकेट और यहाँ पे आ जाएगा 1/2. फिर यहाँ पे अंडर रूट ऑफ, अच्छा 1/2 आ गया. अभी यहाँ पे जो एक्स स्क्वायर प्लस ए स्क्वायर रेज टू 1/2 था, वो 1/2 में से 1 माइनस हो जाएगा. 1/2 में से 1 माइनस हो जाएगा तो इट विल बी माइनस 1/2. सो इट इज नथिंग बट 1 अपॉन अंडर रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर. ठीक है, multiplied by d by dx of x square plus a square, which is d by dx of x square plus d by dx of x square plus d by dx of a square. So what is d by dx of x square? It is 2x plus d by dx of a square is 0 because a is a constant. We consider it as a constant, so we don't write anything over here, plus 0, nothing. So this will be just 2x and the bracket will be closed over here. This big bracket will be closed over here. Now let's simplify this. Now this 2 and this 2 will get cut. Okay, now just pay attention. N multiplied by x plus under root of x square plus a square, the whole upon n minus 1 bracket multiplied by bracket 1 plus this will become x upon under root of x square plus a square. ठीक है, इसको सिंप्लीफाई करते हैं. n मल्टीप्लाई होगा अंदर, मुझे लगता है नहीं होगा. सो दिस विल बी n ब्रैकेट x प्लस अंडर रूट ऑफ x स्क्वायर प्लस a स्क्वायर द होल रेज टू n माइनस 1 मल्टीप्लाइड बाय, यहाँ पे सिंप्लीफिकेशन हो जाएगा अंडर रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर प्लस एक्स द होल अपॉन अंडर रूट ऑफ एक्स स्क्वायर प्लस ए स्क्वायर. ठीक है, ओके. व्हाट वी हैड टू प्रूव, ये कैसे मल्टीप्लाई होगा? यहाँ पे n है, n मल्टीप्लाई होगा तो कुछ समझ में नहीं आ रहा है. यहाँ पे n माइनस 1 है, यहाँ पे 1 है. या दे बोथ हैव द सेम uh, numerator. Yes, 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 they can be simplified. Okay, let me just copy this thing over to here so that we can simplify it further. Yeah, because there is no uh, plus sign, right? So we can definitely multiply this. Okay, so this will become n multiplied by x plus under root of x square plus a square raised to n minus 1 multiplied by under root of x square plus a square plus x the whole raised to 1 the whole upon under root of x square plus a square. Okay, now just be very careful over here. See these bases, I'm just going to highlight this. These two bases are the same and their powers are n minus 1 and 1. The powers will get added. N minus 1 plus 1 will become n. Okay, so this is nothing but n bracket x plus under root of x square plus a square uh, the whole raised to n, okay, the whole upon under root of x square plus a square. Now what do we have to prove? Hmm, we have to prove dy by dx is equal to ny. Okay, do we have y over here? What is y? Y is equal to x plus under root of x square plus a square raised to n. Yeah, we have that. So this is nothing but ny the whole upon under root of x square plus a square. This is your dy by dx. Yeah, so we have proved it. I hope you understood it. इतना कुछ difficult नहीं था. Yeah, so जो चेन रूल है ना उसको अगर तुम लोग यूवी मेथड से नहीं लेकिन डायरेक्ट मेथड से करोगे तो इट विल बी इजियर फॉर यू. ठीक है, सो आई हैव कंप्लीटेड दिस पार्ट. इसके बाद वाले पार्ट्स आई थिंक जितने भी 2 3 4 पार्ट्स हैं they are simple and I'm going to finish them quickly so that we can move to application of derivatives or differentiation. Okay, see you in the next class. Bye bye.